Hello and welcome. Today, we're going to pull back the curtain and learn the fundamental language of computers. We're talking about C, one of the most foundational and powerful programming languages out there. And our goal? By the end of this, we're going to write our very first complete program together from scratch.
So let's kick things off with a simple question. Does a computer have its own alphabet and grammar? And the answer is a huge yes. Learning to program in C is almost exactly like learning a new spoken language. It has its own special words and, maybe even more importantly, its own super strict grammar rules.
And just like any other language, C has a set of rules you just can't break. In the world of programming, we call this the syntax. You've got to get this right because it's the very foundation of how you speak to the computer.
Okay, and when I say these rules are strict, I mean they are absolute. For one, C is case-sensitive. To the computer, a lowercase a and an uppercase A are as different as night and day. Every single command you write has to end with a semicolon. Seriously, think of it as the period at the end of a sentence. And we group chunks of code together with these curly braces. These are not suggestions, folks. One tiny missing semicolon and your entire program will refuse to work.
All right, so we've got a handle on the grammar. Now let's dive into the vocabulary. You see, the C language basically has two kinds of words, the ones it reserves for itself to do special jobs, and the ones that we, as the programmers, get to create and name ourselves.
First up, we've got what are called keywords. The easiest way to think about these is as the built-in verbs of the language. Words like if, while, or int, they have special protected meanings. They're reserved because they tell the computer to do a very specific thing, which means, sorry, hands off. We can't use them as names for our own stuff.
Here's a quick look at some of the most common ones you'll be seeing all the time. Int and float are for different kinds of numbers, if and while help control how your program runs, and return is for sending a result back. Trust me, you'll get to know these guys very well.
All right, time for a little pop quiz. We know we can't use keywords like float or int for our own names. So looking at these options here, which one do you think is a valid legal name that we could actually create in our code? A, B, C, or D?
So, the names that we get to create, those are called identifiers. This is our chance to give meaningful names to things in our program, like variables that hold our data. But, of course, there are some rules we have to follow when we're naming them. And here are those rules. A name has to start with a letter or an underscore. It can never start with a number. It can't have any spaces in it. And, as we know, it can't be a reserved keyword. That's exactly why the answer to our quiz was C. Say I won. It's the only one on the list that plays by all the rules.
Okay, so we know how to name things, but where do we actually put our information? Well, we use things called variables, and you can honestly just think of them as perfectly labeled storage boxes sitting in the computer's memory.
And here's the key. Not all boxes are the same. Each box is specially designed to hold a specific type of data. An int box, that's for whole numbers. A float box is for numbers with decimal points. A double is for super-duper precise decimal numbers, and a char box holds just one single character. Picking the right box for the job is a huge part of writing good code.
So you might be wondering, what's the big deal between a float and a double? It all comes down to one word: precision. A float is fine for most everyday decimals, but a double can hold way more digits after the decimal point. And that's absolutely crucial for things like scientific or financial calculations, where being off by even a tiny fraction could cause big problems. So, what happens if you have data in one type of box, but you need to move it into another type of box? Can you even do that? Yes, you can, and it's an incredibly powerful concept called typecasting. It's really the art of converting one data type to another. Let me show you a classic example that trips up almost every single person when they're first learning C. We've got two integers, 5 and 2, we divide them, and we store the answer in another integer box. Seems simple enough, right? So what do you think the value inside that Sanuk variable is going to be? Now, your human brain is probably screaming 2.5, but remember, we're talking to a computer that follows rules very literally.
The answer is 2, just the number 2. So what on earth happened? Well, because C saw you dividing one integer by another integer, it decided the answer had to be an integer 2. It does the math, gets 2.5, and then just chops off everything after the decimal point. It doesn't round up or down, it just throws it away. Gone.
So how do we fix this and get the answer we actually want? We use something called an explicit cast. By putting float right in front of one of our numbers, we're temporarily telling the computer, hey, just for this one calculation, I want you to pretend this integer is actually a decimal number. And boom, just like that, the computer does what we call a floating point division, and we get the correct answer, 2.5. This shows you the power of casting. The big takeaway here is you always have to be mindful of your data types, especially when you're doing division.
Okay, our program can do math, which is great, but it's not very useful if it can't actually communicate with a human, right? For that, we use two fundamental functions, printf to display stuff on the screen and scanf to get input from the user. You can think of it as the computer's way to speak and to listen. Now, when we use these functions, we can't just throw data at them. We have to give them a little hint, a special code that tells them what type of data to expect. We call these format specifiers. So %d is the code for an integer, %f for a float, and so on. It's how we make sure the command and the data are on the same page. Okay, everyone, pay very close attention. I am about to show you what is maybe the single most common and most dangerous mistake that beginners make in C. This line of code here looks perfectly fine, but it has a critical flaw, and it will almost certainly crash your program. And the fix is one tiny but absolutely vital character, the ampersand, this little and sign. Here's why. Scanf doesn't just need to know the name of your variable box, it needs to know the exact address in the computer's memory where it should store the user's input. The ampersand is what provides that address. Never, ever forget it. All right, we've covered the grammar, the vocabulary, our data storage boxes, and how to communicate with the user. It is time. Let's put all these pieces together and build our very first fully working C program. Let's break this down line by line. Every C program starts in this main function. Inside, the first thing we do is create our integer box and name it Yaz. Then we use printf to display a question to the user. Next, and this is the important part, we use scanf with the right format code, %d, and that crucial ampersand to listen for their answer and store it at the memory address of Yaz. And finally, we use printf one more time to talk back to the user, showing them the age they just typed in. So, let's do a super quick recap. What are the big takeaways? First, syntax. These are C's strict, non-negotiable grammar rules. Second, variables. These are our named storage boxes for holding all our data. Third, typecasting. It's absolutely critical for getting accurate answers when you're dividing numbers. And finally, printf and scanf. These are our essential tools for talking to the user. And that brings us to one final thought for you. Now that you have the absolute fundamental building blocks of programming, what's the first simple problem, the first basic calculation, or the first question you would want to teach the computer how to solve? The possibilities are just getting started. Thanks for watching.